Hi everybody, welcome to the final science review. This is part 2, looking at this final review test before you go to your exam. Let's have a look at these final 18 questions together. Now for this question, we only have a small part of the explanation, but Tanisha is conducting an experiment to determine the effect of watering clover with liquid vitamin B. So the thing that she's changing is the watering with liquid vitamin B. So that will be the independent variable. And the thing that she's measuring is the height. So the height would be the dependent variable. But we're told in the middle, 1 week into her experiment, the average clover plant from her control group is 17.3 millimeters tall. She has a control group. So she must have a group that she waters with liquid vitamin B, and a control group is a normal group. So one group that she does not water. So because we're told that she has a control group, we can guess that there are two different plants that are growing. One that has no vitamin B, the normal group, the control, and one that does have vitamin B, the experimental group. So vitamin B or no vitamin B would be the independent variable, and the amount of growth would be the dependent variable. What can we infer? What can we guess about her experimental design? The design contains an error because Tanisha is only measuring the height 1 time per week. Well, we don't know if she only measures 1 time per week. It says after 1 week, it is 17.3 millimeters tall. We don't know if she measures the height every day or not. But also, some plants grow slowly. So she might conduct the experiment for 2 months and check the height every week. Some plants might grow very quickly, so you might want to measure the height more often. But we're talking about a plant growing. A plant will not grow so much in 1 day, so checking the height every week would seem to make sense. The design contains a flaw because Tanisha is only using 1 type of liquid vitamin. Well, that's a good thing. Remember, when we make an experiment, we want to have 1 independent variable, 1 dependent variable, and then everything else controlled. So having 1 independent variable, vitamin B or no vitamin B, is good. If she starts to add in lots of different vitamins, then the results might be complicated and difficult to prove. C, the design is effective because the vitamin is delivered in liquid form. So you could put tablets, solid form, around the base. You could put a cover over the plant and then put air inside. But what Tanisha is doing is she is watering. So she gets a watering can and she's watering with vitamin B. So if she is watering with vitamin B, it's good, but other ways would also work. C is good, but it's not a great answer. D, the design is effective because she is testing both an experimental group and a control group. This is the important point. If the control group grows 17.3 millimeters and the other group grows, let's just for example, if the other one has grown 20 millimeters, then we can say that the one that's got the vitamin B is growing more. If it's growing more, then there is an effect. We need to have that control group before we can decide if this is effective or not. So D is a very important part. We often need to have control groups. Which sentence from the passage, another one of these questions where we don't really need to read the passage, we need to read the answers from the passage. Which sentence from the passage best supports the idea that driving a hybrid electric vehicle burns gasoline? So driving a hybrid burns gasoline. So we're looking for driving a hybrid car, and we are looking for burning gasoline. A. Many individuals concerned with their carbon footprint are excited about the availability of hybrid electric vehicles. Well, this is the hybrid electric vehicle in it, but it's got nothing about gasoline. So this does not support the statement that we're given. B. These cars are much more efficient in their use of fossil fuels. Their use of fossil fuels. An example of fossil fuel is gasoline. But what is these cars? We do need to go to the passage for a moment. If we go to the passage, we see that these cars are here. And what is just before these cars? Hybrid electric vehicles. So the word these is referring to hybrid electric vehicles. So actually, we do have hybrid electric vehicles in answer B. We have both parts of our idea. C. Hybrid electric vehicles do come with an environmental price tag. That's got the hybrid electric vehicle, but it's got nothing about burning fossil fuel. And then D. Such extraction processes are a type of surface mining which have severe environmental impacts such as erosion, acid mine drainage, water pollution, and disruption of habitat. These are all environmental problems, but there is nothing there about driving hybrid vehicles. And there's also nothing there about burning gasoline. So D has none of the ideas in it. C only has one. The best answer is going to be B. Efficient in their use of fossil fuels means they do still burn some gasoline, but they don't burn gasoline all the time. A normal combustion engine only runs on gasoline, but a hybrid electric vehicle uses gasoline to start and then electric to continue. After analyzing the data, what is the most appropriate conclusion about the effects of caffeine on the heart rate of a healthy 20-year-old woman? Caffeine on the heart rate. So the heart rate would be the dependent variable, and the beverage of which caffeine is an example would be the independent variable, the thing that is being changed. So an experiment was performed to determine the effect of caffeine on the pulse rate of 20 healthy 20-year-old women. Each woman in a state of fasting means not eating food, was given a 250 milliliter beverage at the same time. The women had their pulses measured before they consumed the beverage and then 30 minutes after consuming the beverage. The process was repeated over 5 days with 5 different beverages. So each of the 20 women tried each of the 5 beverages. What can we say? Well, water had no caffeine in it. And the heart rate started at 60, and then 30 minutes later, the heart rate was still 60. There was no change. Caffeine-free soda started at 54 heart rate, and it went up to 55, so only a +1. In the soda, there might be sugar, for example. Caffeinated soda, there was 10 milligrams of caffeine in this, started at 59 and went to 69, so that was +10. Decaffeinated coffee, well, decaffeinated means there is still some caffeine, but not a lot of caffeine. So 61 to 65 was +5. And then regular coffee, the normal coffee that people drink, the heart rate started at 59 and went up to 82, which is +23. So we can see in regular coffee, where there was 45 milligrams of caffeine, the heart rate went up 23. And in caffeinated soda, where the milligram was 10 caffeine, the heart rate went up by 10. So the drinks that had more caffeine increased the heart rate more. So caffeine increases the pulse rate of women. When there was no caffeine, the heart rate did not change very much or not at all, but when there was caffeine, the heart rate increased. A would be a good answer. For B, to say it decreased would be false. We look here, plus 10 plus 5 plus 23. B is false. C, it is safe to consume. Well, there's nothing here about safe or not safe. The heart rate increases. When you're excited, the heart rate increases. When you play sport, your heart rate increases. When you drink caffeine, your heart rate increases. Many things increase the heart rate. If it is safe or not is not included in this passage, so this would be not given. And then regular coffee is healthier than decaffeinated coffee. Well, we don't know how much increase to the heart rate is healthy and how much increase is not healthy. If increasing the heart rate is healthy, then regular coffee is healthier. If it is not healthy to increase the heart rate, then it is not healthier. But we don't know. From the information that we're given, we simply don't know, but A is proven. Now, a computer network, this seems quite strange, but a computer network is a set of computers connected together for the purpose of sharing resources. Network latency is an expression of how much time it takes for a packet of data to get from one point to another. For computer networks to work effectively, it is important to minimize network latency. So for effective work, you need to minimize the latency. The following equations can be used to calculate latency. The network latency is equal to the propagation delay plus the serialization delay. So if we want to decrease the network latency, then we need to decrease the propagation delay and decrease the serialization delay. So which one of these can do that? So firstly, propagation delay is not included and sterilization delay is not included. So what do we have? We have distance, we have speed, we have packet size, and we have transmission rate. So we want the propagation delay to be smaller. So let's say that we start with this formula. The propagation delay is equal to distance over time. Let's just put in some numbers so that we can imagine this. So propagation delay is equal to 2 divided by 2. So we get a propagation delay of 1. If we increase the distance, what would happen? So instead of 2 over 2, we might get 4. If we increase the distance, we might get 4 divided by 2. Well, 4 divided by 2 would give us 2. This would increase the propagation delay. So A is not correct. B, how about decreasing the speed? Well, instead of 2 over 2, let's have 2 over 1. 2 over 1 is 2. So decreasing the speed would also increase the propagation delay. Now the serialization delay is equal to the packet size divided by the transmission rate. And again, to help us imagine, let's just put in the number 2. So 2 over 2 equals 1. If we decrease the packet size, so we're going down on the top number, we would get 1 divided by 2, which would give us 0.5. So this would make the serialization delay smaller. If we decrease the transmission delay, it would be the same as decreasing the speed. It would make the serialization delay larger. So the correct answer is answer C. If we decrease the packet size, we decrease the serialization delay. And if we decrease the serialization delay, then we decrease the network latency. Although this question has lots of words that you don't know, you can use the formulas just like speed equals distance over time. You can imagine what happens if you change one part of the formula, and then you can imagine what the effect would be on the things that are connected to it. Which sentence, again, we don't need to read the passage, we need to read the sentences that we're given. Which sentence from the passage, from the paragraph, supports the idea that species in the same genus can have unique characteristics? So we're looking for something about the same genus, but different characteristics. So A, in July 1957, members of the field party from the University of Kansas Natural History Museum, under the direction of the Sidney Anderson, spent 12 days collecting vertebrates in the vicinity of Creel in southwest Chihuahua. So they collected vertebrates. This is a description. We don't have about the same genus, and we don't have about the different characteristics. This is just a description of what they did. This does not support or reject the suggestion. B, the Geophis aquilionaris is different from all other different from, so unique characteristics. To be unique means to be the only one. So different from all other is the same idea as unique. Mexican representatives of the genus. So the Geophis aquilionaris is different to all the other representatives or species of the Mexican genus because it has numerous alternating pale and dark bands on the body and tail. This would be the characteristic. The alternating pale and dark bands on the body and tail would be the different characteristics. So B supports both parts of the idea. C, among the specimens taken were 2 snakes representing an undescribed species of the genus Geophis. Well, we do have about a genus, but in answer C, we don't have anything about different characteristics. So C cannot be correct. And then D, the discovery of the new Geophis species in southern Chihuahua increased the number of species in the genus known to occur. Increased the number of species. It did not have anything about characteristics. So although the species is included in answer D, the characteristics is not. So D cannot support the idea that we are given. Whenever you get a question like this, that you're trying to support an idea with a sentence from the passage, look at how many different parts of the idea there are and try to find those parts of the idea in the sentences. And then ask yourself, is this evidence or is this a suggestion? What can be inferred from this passage about the differences between Neptune and Saturn? Neptune is icier than Saturn. Neptune has more moons than Saturn. Saturn is smaller than Neptune, or Saturn is rockier than Neptune. Well, there are 2 types of planet in the solar system, terrestrial and Jovian planets. Terrestrial planets are the inner planets or the rocky planets. They are smaller in size, higher in density, made mostly of rock and metal and close to the sun. They have few moons and no rings. The Jovian planets are the outer gas giants. So rockier is about the terrestrial planets, that's Mercury, Venus, Earth, and Mars. It's not going to be about being rockier. They are larger in size, lower in density, and made mostly of gases, further from the sun. They have ring systems and many moons. There is also a subclassification of outer planets, outer gas giants, known as ice giants. Ice giants are smaller in size. So ice giants are smaller. Just make a note, they are smaller. They are smaller in mass. They have lower amounts of gas, less gas. And more rock and ice, more ice. Which are the ice giants? Well, Neptune and Uranus are the ice giants. So Neptune is smaller. Neptune has less gas. Neptune has more ice. The correct answer must be A. Neptune has more ice than Saturn. What percentage of the total energy consumption is produced from biofuels? Who looked there and said answer is D, 21? You would be wrong. The answer is not D. Why not? Well, what percentage of total energy consumption? So this is the total energy consumption. Of total energy consumption, 9% is renewable. Renewable includes solar, geothermal, waste, wind, biofuels, wood, and hydroelectric. Renewable includes all of those. So each of those must be less than 9% of the total. So what do we have? Well, we have that biofuels is 21% of 9%. Biofuels is 21% of renewable. And renewable is 9%. So we need to times 9 by 0.21 to find out what the percentage is. So we get the answer 1.89. Information about the composition of the ocean water is listed in the table above. Which statement is supported by the data in this table? So we should be thinking, is the statement true or false or not given? A, there is more potassium than magnesium. So potassium is 0.03, magnesium is 1.3. Magnesium is more, potassium is less. So answer A is false. B, there is more chlorine in the ocean than sodium and sulfur combined. Chlorine is 1.9. And this has to be more than sodium, which is 1.05, and sulfur combined. Well, sulfur is 0.0885. So if we add those together, we get 1.9 is greater than 1.3885. That's true. So B is the answer that we're looking for. C, if bromine was more highly concentrated, then it could be extracted for use in disinfectants. If this happened, well, this is not given. We don't know what would happen. This is only the composition of the ocean water. We know how much of each element is in the water right now. We do not know what would happen in the future. We have no idea. D, carbon plays a small but important role in the ecosystem of the ocean. Well, carbon does have a small role. This part would be true. Important, there is nothing in the table that tells you it is important. There quite likely is an important role. It might be used for the plants that live in the ocean. There you see my word, it might. It might be used by the plants that live in the ocean. This table does not tell me it is used by the plants that live in the ocean. That would be my imagination. The only one that is proven by the table is answer B. So if we're asked for a statement that is supported, think very carefully about true, false, and not given. In a velocity time graph, acceleration or positive velocity is represented by the steepness of the line. Deceleration or negative velocity is represented with the slope downward. So here we have positive acceleration because it's going up. Here we have negative acceleration because it's going down. Here we have zero acceleration. That means the speed is not changing. Assuming that the graph above demonstrates a sprinter's velocity over time, sprinter means a runner, how would you best describe this graph? The sprinter accelerated for the majority of the duration of the chart's plotting time. Well, the sprinter accelerated from 0 to 4. Then the speed stayed the same for 4 to 7. So for 4 seconds, accelerated. For 3 seconds, stayed the same. And then for 3 seconds, decelerated. That doesn't make sense. It took longer for the sprinter to decelerate than accelerate. Well, decelerate is another way of saying negative velocity. So for the deceleration from 8 to 0 meters per second, it took 3 seconds. The acceleration was from 0 to 4. So the acceleration was 4 seconds, deceleration was 3 seconds. So it did not take longer. B is false. C, the sprinter achieved the greatest positive velocity. Well, positive velocity means going forward. The greatest positive velocity would be this part here. Let me clean off some of this. The greatest positive velocity would be this part here. The greatest velocity is 8 meters per second. During the middle of the race, well, this is from 4 to 7 seconds. We can say that that is the middle of the race. C looks like a good answer. D, the sprinter maintained the same velocity after a burst of increasing acceleration. Well, there was the same velocity until 7 seconds, and then there was negative acceleration. The speed went down. The speed did not stay the same until 10 seconds. So this is wrong because the line did not stay the same. It started to have a negative acceleration. The correct answer is C. According to the following graph, measuring plastic particle concentrations at specific depths of the ocean, which of the following statements is true? So again, we should be looking for true, false, not given. A, there are more particles at the surface than deeper in the ocean. Where is the surface? Well, the surface would be 0. If the ocean depth is 0, this means the surface of the ocean. This is 100 meters below the surface, 200 meters below the surface, 300 meters below the surface. So this is getting deeper. This is the deepest. And the 0 is the surface. It's just like height, actually. When we talk about height, we talk about meters above sea level. So 5,000 feet means 5,000 feet above sea level. Sea level is 0. If you get a plus, then you're going upwards. If you get a negative, you're going downwards. B, the greatest concentrations appear to be at depths of between 100 and 600. So 100, 600, 100 and 600 meters below the surface. This just has some plastical particles. It does look like most of the plastic particles are just below the surface. So B does look true. C, the highest concentrations of particles are at deepest depths. Well, the deep depths, the concentration is lower. So that one is false. Actually, C and A are pretty much the same. So there is almost the same concentration at the surface. At the surface and at deep depth, the concentration is almost the same. The concentration gets highest around this area here, which is below 100 meters, but above 600 meters. So that's why B is the best answer. Gravity is a force which tries to pull two objects towards each other. Anything which has mass also has a gravitational pull. The more massive an object is, the stronger the pull will be. So bigger objects have more gravitational pull. Earth's gravity is what keeps you on the ground and what causes objects to fall. Gravity is what holds the planets in orbit around the sun and what keeps the moon in orbit around the Earth. The closer you are to the object, the stronger the pull is. Gravity is what gives you weight. Gravity is what gives you weight. It is the force that pulls on all your mass in the body. So weight is the calculation of the effect of gravity on the mass in your body. As objects move away from the Earth, what gravitational change would occur? And how does that impact the weight of an object? Well, the first thing to see is that when you are close to an object, the gravitational pull is stronger. So if you're on Earth and you start to move away from the Earth, the pull will get weaker. So let's look at that first. A, the pull will become stronger. B, the pull will become stronger. C, the pull will become weaker. And D, the pull will become weaker. A can be removed and B can be removed. We're looking for the idea of the force becoming weaker. So weight is the effect of the force pulling on the mass in your body. So if the force is lower, then your weight would decrease. Okay? But if the force is 10 and your weight is 6, so your mass is 6, then you get a weight of 60. But if the force goes down to 5 because you are moving away from the Earth, your mass would still be 6, but you now have a weight of 30. Those numbers are just an example. Don't think about what the numbers represent. I'm just trying to show you that the force would decrease, but the mass would stay the same. So the weight calculation would be decreasing, not increasing. That's why answer D is correct. Which of the following could directly lead to an increase in the ladybug population? So we want to have a direct effect. We want to increase the ladybugs. So stabilizing the ant colony, growing the aphid population, increasing the honeybees, or declining the leafhopper. So Jane wants to feed her family healthy, nutritious, organic food without spending a lot of money. She decides to plant her own garden to accomplish these goals. Next to her garden, she builds a system to collect rainwater for the plants. For plant health, Jane opts to use beneficial lady beetles, more commonly known as ladybugs, to control the pests in the garden. So she's going to use the ladybugs to control the pests, to decrease the other insects that would eat the plants. Jane learns that the ladybugs are the natural enemies of garden pests like aphids, mealybugs, and leafhoppers. Ladybugs benefit the plant in a number of ways. While they prefer to feed on aphids, they feed on the aphids. They also eat other food like pollen and nectar, and they are also pollinators. And Jane will also be alert for signs of an ant colony. Ants that feed on the products of aphids can attack and drive off the ladybugs. So ants can drive away the ladybugs. So if there is a stabilized ant colony, they will drive away the ladybugs. That would decrease, not increase. The ladybugs do like to eat aphids. So if there's more aphids, growing aphid population, then there's more food. More food means a higher carrying capacity. So more ladybugs could survive. B looks like a good answer. Honeybees are not really linked to the ladybugs. They're not mentioned here. They are pollinators, but they are not mentioned to the ladybugs. In the leafhopper population, there is the inference that the natural enemy could be because they eat them. So there's an inference that the ladybugs might eat the leafhopper, but it's not clear. And if the leafhopper declines, then if they do eat them, then there would be less food. So that would not be good. So answer B is the best answer. Jane's garden acts as a small ecosystem composed of both living and non-living factors. Which of the following incidents could cause a severe imbalance in this environment? Well, if there was an extended drought, that means there would be no water for a long time. A drought means there's no rain. If there's no rain, the plants start to die. If the plants start to die, the animals either die or move away. So if there was a drought for a long time, then there would become an imbalance in the environment. Things would start to die or start to move away. Pesticides in the rain runoff might affect some animals, but not affect widely. Addition of composted soil might make things grow more, and if there's more plants growing, then more animals can survive. So that would be positive, not negative, and an imbalance would be a negative thing. And then genetically modified seeds would alter the ecosystem. There'd be new plants growing, but they could be good or bad. We don't know. Some genetic modifications are good, others can be damaging for other organisms that live in the same place, but we don't know. So only A is a huge negative effect. Now, based on the passage, which statement best summarizes the location of crude oil? Permeable rocks found underground trap crude oil inside rocky domes. Or oil is usually found inside impermeable rocks underneath the ocean floor. Crude oil is found trapped in some of the sedimentary rocks of the Earth's crust. Or in areas of high temperature, dome-shaped rocks near the fault lines house most of the oil. Scientists can often tell where the crude oil is trapped by looking at the shape and the structure of rocks. Oil tends to be located where permeable rocks are in contact with impermeable rocks, so where there are permeable and impermeable rocks connecting, at a fault line, or where impermeable rocks are domed upwards. Impermeable rocks domed upwards. Well, we do have inside impermeable rocks here, so that's possible. Or dome-shaped rocks near fault lines, that could also be possible. Let's continue. Crude oil formation began millions of years ago when microscopic ocean plants and animals died. The remains were covered by many layers of sediment that eventually turned to rock. As the temperature and the pressure increased, the organic remains slowly changed into crude oil. So the ocean plants slowly changed into crude oil. That oil is extracted by drilling through impermeable rocks. Permeable means liquid or something can go in and out. Maybe water can go in and out. Impermeable means water cannot pass through. So if the rock layer is impermeable, liquid cannot pass through, so the liquid would be trapped underneath. So we do have about ocean plants, and we do have about under the ocean floor, and you have to go through the impermeable rocks and inside impermeable rocks. B looks like a good answer. Now, which of these arguments might be used by a proponent of oil as an energy source? So proponent means in favor. So somebody who agrees with using oil. So we're looking for a good thing about oil. Replacement sources of energy are costly to implement. So people should continue to use oil. That is good for oil. Replacement sources of energy are cleaner for the environment, so people should change to renewable energy. Changing to renewable energy is bad for oil. That is stopping using oil. So it cannot be B, because we look for a proponent, a supporter of oil. Oil is an abundant resource, so there is no need to stop using oil as an energy source. No need to stop. That is about good for oil. And then D, oil might run out, so people should begin to use something else. People should change. That is bad for oil, so take away answer D. So by looking at the answers, firstly, we see two of the answers are not in favor of using oil. So take away answer B and D. We only have two answers left, A and C. One option is that it is expensive to change, so we continue to use oil. The other option is oil is abundant. There is lots of it, so we don't need to stop. What does the passage say? There are concerns about the world's population's dependence upon oil. Unless oil is used more efficiently, supplies of crude oil could run out in the next 30 years. Or supplies could run out in the next 30 years. So oil is not abundant. It's not abundant. This is not a reason to keep using oil. But the paragraph does go on to say, replacing oil with renewable energy costs a lot to research and implement. To change, to choose to use something else, costs a lot of money. It's expensive. So that's a reason not to change. Answer A is the correct answer. According to the graph, what is the race car's acceleration between 0 and 10 minutes? How do we work out the acceleration? Well, acceleration is equal to the final velocity minus the initial velocity divided by the time. So at 0 minutes, the velocity is 0. So acceleration equals the final minus the initial divided by the time. So we are minusing 0. What is the acceleration after 10 minutes? It's 6,000. What is the time? Well, we're looking at 10 minutes. So this is 6,000 minus 0, which is 6,000, divided by 10, which is 600. So the correct answer is 600 meters per minute squared. If you chose 0, then you took the beginning and the end, and you had 0 minus 0 divided by 55, which would give you 0. But it doesn't say for the total time of the graph, it says in the first 10 minutes. So we're only looking at this section of the graph. If you got C for 100, then you might have been looking at the first 20 minutes. Because if you took this point here, which is 4,000, possibly you're looking at that. If you got a minus number, then you might have been looking at the first 40 minutes, where you had a minus 4,000 minus 0 divided by 40. So it's very important you read the question carefully. You find those numbers on the graph. And when you found those numbers on the graph, then you put the numbers into the formula. And as I've said many times before in these videos, I start by writing out the formula, and then I try to find pieces of information by looking at the text and by looking at the graph. So this is the final velocity, 6,000. This was the initial velocity, 0, and the time was taken from the question of 10. Now we have one of these experimental method questions. A teacher tells Jack that rougher surfaces have more friction between them than smoother surfaces. That's why governments put sand on icy walkways and roads. People can't slide as far across ice with shoes as they can on blades of skates. The rougher the surface of the sole of the shoe causes more friction and slows down the person. So this is the information. This is what Jack learns. But then we have a question. Jack knows that the school is planning to resurface the school hall. So they're going to put a new floor in the school hall. And they're thinking about what type of material to use. So the question is, what type of material should they use? He says they should choose a rough material, because this will reduce the chance of students slipping and hurting themselves. He does not want a smooth floor, he wants a rough floor to reduce the chance of slipping. He designs an experiment to prove which type of surface is the most suitable. So let's look at the steps. We should know by now we have forming a hypothesis, which is guessing or predicting. We have designing a test, which is planning. We have collecting data, which might be something about recording or doing. And then we have forming a conclusion, doing analysis. Was he right or wrong? Or the car travels furthest over the polished wood and least far over the carpet. He concludes, the school should be carpeted to increase friction and reduce the risk of students slipping. He's making a conclusion based on what he saw. He saw the car traveled furthest over polished wood. He saw the car traveled less far over a carpet. So he made a conclusion. Jack chooses 4 possible surface materials: plastic, polished wood, unpolished wood, which is what we have in the dormitory, and carpet. Polished wood is where you use a liquid to make it shine. He plans, he's planning, he's not done yet, he's still planning to cover a ramp with them and measure how far the car will travel. Will travel, future tense. He's planning to do this. He's thinking what will happen. He's not done this yet. So this is the design. Jack thinks that smoother surfaces will produce less friction and make it easier for objects to travel over. So the school should be rough to stop students slipping. He thinks. He thinks means he is making a hypothesis. He is guessing. And then finally, Jack builds 4 ramps. He does it. Each one is the same height, but covered with a different material. He rolls the same car down each 4 times and measures, records how far they travel. Then he calculates the average. These are all things that he does. This is conducting the experiment. It's collecting data. So which of the following would be a source of error in the investigation? And we have to refer back to the previous slide where we're thinking about what things he did. He used 4 different materials for the ramp, but the independent variable was the type of material. So using 4 different materials is not bad because he's changing the independent variable 4 times. The dependent variable was, what do you think? It was how far the car traveled. So using 4 different materials is good. He has to use different materials because he has to change the independent variable. Using the same car each time is good. Different cars have different tires, different weight, different speeds. Building the ramps to different height, well, if one ramp is high and one ramp is low, then the car at the top of the high ramp will have more potential energy than the car at the top of the low ramp. So the car at the top of the high ramp will get more kinetic energy as the potential energy changes into kinetic energy as it goes down. So because there is a difference in the ramp height, you could not say the difference in the distance traveled is due to the type of material. You would have to say the difference in the distance traveled could be because of the material, or it could be because of the height. When it could be one thing or could be another thing, you have an error in your investigation. An investigation should only have one thing that can be responsible for the change. That's why we only change the independent variable and keep everything else the same. Having the same force on the car at the top of the ramp is also good. Repeating 4 times on each material is also good. And then calculating an average, sometimes things go wrong. Sometimes you get a random effect. So repeating 4 times and calculating the average is also a very good way to reduce potential errors in the investigation. And that's the end of this video. Hopefully it's been useful. Please do think about how to answer the questions. Don't just worry about the right answers, but think about how to find the right answers if you get these types of questions in your exam. Oshla Saikoda.